why does sine of 1 over x automatically go to 0? Okay, let's have a look. Right here, I'm going to answer your question first, and then I will talk about these two limits because they all look very similar. For the first one, the limit as x approaching infinity of sine of 1 over x, that is equal to 0 because we can do the following. As x approaching infinity, let's put infinity to here. So we get sine of 1 over infinity. And right here, right now, I will have to say, some people might not like the things that we are doing here. In that case, just don't let them see it. And some people don't like to see this kind of expressions. Well, the key right here is that we are going to reason this inside out. Inside, we have 1 over infinity. A finite number over infinity, we get to draw a conclusion, and that is, this is going to be 0. Right here, we know this is approaching sine of 0. And notice that I'm using an arrow right here instead of the equal sign because it's approaching, so technically I'm taking the limit. And then sine of 0, of course, that is going to be going to 0. So we are done, just like that. Now for the next one. The limit as x approaching infinity of sine of x over x. This is also 0. Why? It's a little bit weird if you plug infinity into all the x's. We get sine of infinity over infinity. Well, how are we going to make a conclusion for sine of infinity? In fact, if you just have sine of infinity, meaning if you just have the limit as x approaching infinity of sine of x, that does not exist because the sine function goes up and down in between of -1 and +1. The sine function does not approach the y value when x goes to infinity. However, the key right here is that note, I'm just going to put a note right here. I'm going to draw it right here. When we have a sine function, sine of x is always in between of -1 and 1. And you can also use absolute value. Then you can say absolute value of sine x is less than or equal to 1. Well, the key right here is that I'm not going to put down sine of infinity on the top, but instead I'm just going to tell you at most 1 on the top. Or more importantly, you can also say finite, because the key right here is that the top is always finite. When you have a finite number over infinity, we get to draw a conclusion. That is, this approaches 0. Yeah, so this is how you can reason it out. However, again, some people might not like the things that we are writing right here. The more rigorous way to say the answer is 0 is that you have to use the squeeze theorem. Yeah, we can talk about that in another video. Now for the third one, we have the limit as x approaching infinity of x times sine of 1 over x. Well, the answer is 1. It's not 0. And you might be wondering, this right here, we did it earlier, it gives us 0, but don't forget we still have the x in front. And if you put infinity into all the x's, we get something like infinity times sine of 1 over infinity. This part, is going to be approaching 0. So we are going to get infinity times 0. And that is an indeterminate form, meaning that we cannot draw any conclusion. It's not true when you have 0 times anything, it's always 0. Especially when you're talking about limits. When you have infinity times 0, it's indeterminate. We will have to do more work in order to figure out the answer. And the answer for this is equal to 1. For this one, I have to do it slightly more legitimately. Here we go. Limit as x approaching infinity, x times sine of 1 over x. This is the indeterminate form that we don't like. We like to have 0 over 0 or infinity over infinity. Let me bring this x down. This is going to be the limit as x approaching infinity. Keep this on the top. We have sine of 1 over x. But that's going to be divided by this x down, so it's 1 over x. Why? Because you can just flip it and then you get the x right here. So it's like you bring this down. That's what I mean by that. And this is beautiful because notice 1 over x and 1 over x match. Right here, I'm going to do a substitution. Let angle theta equal to 1 over x. And the key right here is that when x is going to infinity, we have 1 over infinity for theta, so theta will be approaching 0. So right here we are talking about the limit as theta approaching 0, and then for the expression here we have sine of theta over theta, and this right here, the result is equal to 1. And this is the classic limit, one of the first limits that you should have seen in your Calculus 1 class. And right here, I will have to tell you, it looks like we can just plug in 0 into here and here, and we get like 0 over 0. But we cannot cancel out the 0 and 0 and say the answer is 1. When we have 0 over 0, that's an indeterminate form. We don't know what the answer yet unless we do more work. But for this one, it is equal to 1, okay? And that's the answer for this one. So these three limits are very similar. Be careful with them.